Okay, we'll proceed now. If you recollect the previous class ideas, we ended up some speeds like this: RMS speed, RMS speed is equal to 3 RT by m naught. Average speed is equal to 8 RT by pi m naught. And the most probable speed, just I wrote it, I had to define now. What do you mean by that? Is it all molecules, they move with VRMS? No. So in the container, what do we get? Look at this. In the container, what do we get? We get molecules, we'll get molecules, what happened? Speed of molecules vary from 0 to infinity. Of course, infinity not possible. It should be less than speed of light. Theoretically, I'm just putting that statement. Infinite speed should not be possible. So when I plot the speed distribution, I think this is what. And what about the molecules? So will a given molecule will move with the same speed? No. So as it is moving, it will encounter collision. Due to collision, the speed of molecules will be changing here. So first, there's a basic idea. Speed of molecules vary from 0 to infinity. Speed of individual molecules are continuously changing due to collisions. Collision between what? Collision between the molecules and also between the molecule and the wall. Suppose say if a molecule is moving like this with a speed v1, it will encounter collision. Due to collision, now it will start moving. Again, it will encounter collision. Now there's a wall, it will go and collide. And after collision, it will be like this. Are you getting this one? So it is what collision occurs. There's a method of showing that one. So a given molecule itself will not move with a constant speed. Its speed will be continuously changing. There's all the things. Okay, there's a basic idea is what we needed here. So now, so what happened? The Maxwell's, he gave this particular quantity called as NV dN by dV. We'll call this one. So this is called like it's called Maxwell Boltzmann speed distribution function. So what do you mean by dN? What do you mean by dN? Number of molecules with speeds between V and V plus dV. Not volume, it should be between V and V plus dV. Okay, this one. So, that particular dN by dV. So here is what we have expression. So let's not bother how this equation has come. It's not there for our syllabus also. Just will. No need to remember also, I suggest you. So there's the expression for what is N. N means number of molecules. M means mass of molecule. K Boltzmann constant. T temperature. V means speed. The speed distribution. dN by dV. I think this is what I'm writing. Number of molecules with speeds between V and V plus dV. That is what dN means. And also like this, we define Maxwell Boltzmann speed distribution function. This. So when I plot this, and what is capital N? Capital N is total number of molecules. Minus mv square, no, it is e to power of.
Okay, sir. Thank you, sir.
To the power it is e to power of that one. Okay, this is no need to remember. Just we have to have a plot of graph that one. So when I plot this graph, it's there in book. Just have let's have a look. That's all. We need to go in detail. I think maybe in chemistry you need it in detail. In physics, just a basic idea. That's all. Let it be this one. So how the curve will be? So look at this part. Till where, sir? Till where? You can extend till infinity like this. Okay, this is called like a most probable speed. Then we'll get average speed. Then this will be RMS speed. At a given temperature, we are plotting that one. We do have some molecules whose speed will be very less. Why? Okay, we can't give any explanation. We do have some molecules where they'll have very high speed. What about their number? Their number will be less. And the most of the molecules, they'll have one certain speed that is called like a most probable speed here. And there are some molecules in the container which will be moving with a speed equal to VRMS also. And yesterday, still the VRMS. What is VRMS? We don't know. Okay, I'll try to give suitable explanation. I asked you to, most of you to think on that. So in a container, what will happen? We do get some molecules which are moving with a speed equal to VRMS, very much greater than VRMS, and very much less than VRMS also. And what happened to speed of a given molecule? Continuous will be varying. And at a given instant, there'll be some molecules which will be moving with a speed of equal to VRMS. And most of the molecules, they'll be moving with a common speed that is called like a most probable. Now you look at the area, this area and this area. I think this area will be more, no? Are you able to look at this one? So now number of molecules that are having speed less than VMP, their number will be less than the number of molecules which are having speed more than most probable. Will I agree? Most of the molecules that have a speed, so that particular speed is called as most probable, that one. So you look at this area, definitely will be greater than this area, no? So I think I'll shade it. This information also very important can be after just a statistical information. Yeah. this area, and the right hand side will take the definitely which area, yellow color area will be more than that one. No? So what do you mean by that? Number of molecules whose speed less than, whose speed more than VMP, most probable speed is more compared to number of molecules whose speed is having less than VMP. Okay, like this regarding the area we can write here. So what is the conclusions we can make it here? Looking at this curve, let's write something. Huh? What is VMP? Most probable speed. So how you define? The speed with which most of the molecules will be moving. The speed with which will be moving. Okay, this is the thing now. Huh? There are some molecules which will have speed greater than VRMS, less than VRMS. There are some molecules and also equal to VRMS. Okay, fine. Next again, one more thing. The number of the number of molecules which are having speed less than VMP is more than the number of molecules which are having a speed more than VMP. VMP is what? Most probable speed. So if you ask this number and this number should be more, no? So first of all, what do this area under the curve will give? Number of molecules. Better let me put here. Area under the curve gives number of molecules. So therefore, shall I say that number of molecules having speed more than VMP is greater than number of molecules having speed less than VMP? Number of molecules having speed more than most probable speed is greater than okay, these are the some fine. So there's about things. So what about the number of molecules which are having a very high speed? Their number is less. Number of molecules which are having a speed very low, the number also less here. So let me dump here only. Number of molecules having high speed is very small. Is very small, all right. Okay, I mean to say this one. Huh? Number of molecules that are having very high speed, number of molecules that are having very low speed, their number is very small. Or very small number of molecules have high speed and low speed. Okay, this is about the particular graph here. So if I increase temperature, what will happen? Next thing, as I increase the temperature. So if I increase the temperature, let me plot the, Everything should touch this one, no? Like this one. They may ask graph also. You have to be careful. Huh? Oh. Okay, this is the basic thing, that one. So there's a temperature. At various temperatures, we can just plot this particular curve. Sir, what can you say anything about temperature? Temperature should increase, no? Here you mean to say. So I'll put it 150 K, 300 K, 400 K, 600 K. This is NV. And this is the speed distribution of the molecules. This will be 500. Okay, so as the temperature increases, what will happen to curve? The curve will get broadened. So definitely what will happen to the most probable speed will also increase. You can see that one. So as the temperature increases, the most probable speed will also increase. And what will happen to energy of all the molecules will increase. That's what you mean to say. The speed of all the molecules will increase. So RMS speed will increase, most probable will increase, average speed also will increase. So therefore, as you increase temperature, the speed of all molecules must increase. Is it okay? No? So there's one more important conclusion. As the temperature of gas increases, the speed of all molecules will increase. As the temperature increases, what will happen to area under the curve? The speed distribution will change, but number of molecules, how many are there, will be that much only. No, I don't think so. I should look at in terms of that one. In a container, I'll fill up some, say like a 10 to the power of 6 molecules. You increase temperature, what will happen to that? The number of molecules will remain same. No, only the energy, the speed distribution of that will change. Okay, in terms of that, and it will get broadened. The curve will get broadened. So what happened to most probable speed? All the things will increase. Okay, this is about the some related to this particular curve. So as the temperature of gas increases, the speed of all molecules will increase, or the curve will get broadened. The curve gets broadened. Okay, once again, our question was where? Our question is something like, sir, what is that VRMS? Okay, let's do one thing. I think I have put a statement. At the increased temperature, the speed of all molecules will increase. If speed of all molecules increases, tell me what will happen to kinetic energy of all molecules will increase, no? So therefore, what is the total energy of gas? The total energy of gas, I'll come out of this discussion. We'll go for now, energy of a gas. Internal energy of a gas. So overall, according to assumptions, what is the total energy of a gas? Should be only equal to kinetic. What is the energy of the gas? In what form the molecules can possess energy?